Let us start this very important topic of free fall. In this chapter, we'll be talking about acceleration due to gravity on Earth, what it means. We'll simplify its understanding. In this same very chapter, we'll be also talking about one very important topic of terminal velocity, which many students kind of get confused, but we'll clarify every fundamental of this topic and understand this topic very nicely. So this is our lesson 5 on motion. So far we have understood and learned the distance time graphs, its various concepts and fundamentals. We have learned about acceleration, we have learned about speed time graph, and also we have solved some past paper questions or exam style questions on these topics. Let us now understand about free fall. Let us start this chapter by understanding the acceleration due to gravity. We all have heard this term, acceleration due to gravity, and its value is 9.8 meters per second square. So what does it actually mean? It is an acceleration, right? So first of all, let us be clear. When we say G, what is G? It is a acceleration. And when does this acceleration occur? When some object falls under the influence of gravity. So G, when we say 9.8 meters per second square, you should be very clear about it. G is not a speed, G is not a force, G is not a time, distance or any other entity. G is a acceleration. Let us understand what it means with the help of an example. When an object falls freely under the influence of gravity, it is called free fall. Falls freely under the influence of gravity. So here in this topic, we'll be talking about gravity a lot. So let us look at this picture. Here in the picture, you see a boy. He is dropping a ball, right? The ball is dropping under the influence of gravity. This process of falling under the influence of gravity is called free fall. So free fall is not something very technical to understand. Let us understand more concepts. When the object falls, its velocity increases with every passing second. Now this is something that we need to understand. When the object is falling down, it is not falling down at a constant velocity. As it falls down, it is gaining velocity with every passing time. Say that these positions of the ball that you see in the picture are clicked after every 1 second. So at the 0th second, the ball was at this location. After 1 second, this is the new location. After the next 1 second here. After the next 1 second here. So with every passing time, if you see, the spacing between the balls is increasing. Why? More distance is covered in the same 1 second. More distance as compared to the previous distance. More distance in the same 1 second. Next second, if you see, next 1 second, more distance covered. More velocity. The ball is gaining velocity. Higher distance in the same time means higher velocity. So how is this velocity increasing? Okay, let us read this statement again. When an object falls, its velocity increases with every passing second. Its rate of increase of velocity is constant. What is that constant? We denoted it by G, and the magnitude of G is 9.8 meters per second square. So let us, for simplicity of understanding, let's round up this number to 10. So usually in physics, G is also taken as 10 meters per second square to simplify our calculations. So let us say that this ball at the 0th second, its velocity was 0 meters per second. This is the 0th second, and after 1 second, this is after 1 second, the ball has reached this location. What is the new velocity? The the velocity is increasing every second by 9.8 meters per second. So the velocity here is 10. We are taking 9.8 as 10. 10 meters per second. After 2 seconds, this is the new location of the ball. After 2 seconds, this is the new location. What is the new velocity? Again, there is a increase of velocity by 10 meters per second. So now the new velocity is 20 meters per second. After 3 seconds, the new velocity is 30 meters per second. After 4 seconds, the new velocity will be 30 plus 10, 40 meters per second. After 5 seconds, new velocity will be 50 meters per second. So this is what it means. This is what an acceleration of gravity of 9.8 meters per second square means. It means that with every passing 1 second, every next 1 second, the velocity is increasing by 9.8, or for simplicity's sake, 10 meters per second. The rate of increase of velocity is 10.8 meters per second square, and the velocity is increasing by 10 meters per second. This is what the concept of G means, right? Acceleration, if you don't remember the formula for acceleration, it is the change in the velocity over the time taken for this change, right? So if the time taken we are taking as 1 second, right, the change in the velocity is same as acceleration. So here if you see, time we are taking, the time intervals we are taking everywhere is 1 second, and the change in the velocity is constant. The change in the velocity is constant as 10 meters per second. 10 meters per second square, right? Make sense? Okay, so the value of G also depicts something else. This is your point number 2. When an object is thrown up, when an object moves up, its velocity decreases. We know it from our common sense. We all have played with the balls. We throw the ball up, we see that the velocity goes down. Ultimately, it stops and comes down, right? Velocity decreases. And what is the rate of decrease of velocity? The rate of decrease of velocity is again a constant, and it is the same G, which is 9.8 meters per second square. Let us understand point number 2 in the next slide. So when an object is thrown up, its velocity decreases with every passing second. Its rate of decrease of velocity is constant, 9.8 meters per second square. This is a statement which we have taken forward from the previous slide. Let us understand with the help of an example. A ball is thrown up with a velocity of 30 meters per second square. You are throwing up a ball with your hand. Initial velocity is 30 meters per second. For the simplicity of calculation, let's take G as 10, which is approximately equal to 9.8 meters per second square. So if the velocity is decreasing at a rate of 10 meters per second square, what will be the velocity after the next 1 second? So these pictures are clicked at an interval of 1 second. So what is the velocity at this location? The initial velocity was 30. After 1 second, the velocity as it goes up, it decreases by 10. So the new velocity is, you are right, it is 20. After 1 second. After the next 1 second, what is the new velocity at this location? Think about it. 10 minus this velocity. The velocity will decrease by 10 after 20 here. So 10 meters per second in the second second. Third second, What is the velocity at the topmost position? 0. 10 minus 10, it decreased by 10 again from here, 0. It takes a turn and comes back. Now what is the rate of increase of velocity? It is also the same constant g, 9.8 or 10. Right, so what is the velocity at the fourth second? At the fourth second at this location, it is 10. At the fifth second at this location, what is the new velocity? 20. How do you get this 20? This old 10 plus 10, right? What is the new velocity at the sixth second? Sixth second will be here, 30. How do you get this 30? Plus 10. So here, when you were going up, you were doing minus 10. 10 is what? G. So 10 is what? G. Minus G gave you 20. Minus G here, or minus 10, gave you 10 here. So minus G or minus 10 gave you 0 here. As you're coming down, you're doing plus G, right? Plus G or plus 10, plus G, right? You're getting the new velocity second by second. So that's the significance of G. G is 9.8 meters per second square on Earth. That's also one fundamental to understand. The value of G, the acceleration due to gravity, is different on different planets. So when we say that G is 9.8, we are talking about the planet Earth. Different planets have different value of G, right?